I like talking about that car example because most of us have driven and been places and stuff. If you ever been other places where they detect things by technology, speed detectors and cameras and stuff, this comes in very handy. We actually have a theorem that we use in calculus that describes this exact thing that happens in the real world. You know, what happens if someone hits you with a speeding ticket, but they was never there to clock you though? Like, how is that even possible? So here's the graph that I drew. Starts right there at 0. And remember, this is in hours. So we got 0 to about 3 hours that you can see here. And all this is in miles. So if you follow along this curve, 3 hours later, I stop right there. So at 0 hours, I'm at 0 miles. But if we follow this, at 3 hours, I'm at 240 miles. All right. So 3 hours later, I traveled 240 miles. Most people come up with the same conclusion with that question. They will come up with 80 miles per hour average. Because if you take the 240 miles and you divide it by 3 hours, there's your average right there. So that's what we're talking about so far. Visually, all we have to do is connect the dots. You connect the starting dot with the ending dot, and then you literally 240 minus 0, 3 minus 0. That gives you your miles per hour. So my average is this straight line right here. Over the course of 3 hours, my slope is 80 miles per hour, all right? But this dot lets me know the one instant when I was also 80 miles an hour. And so I matched my 80 miles an hour right here at this point, and it happened somewhere around 1.6 hours. So somewhere in between 0 and 3 hours, I made it to 80 miles an hour. That's when it happened. This theorem helps us figure out, when does this instant rate of change, this one time, when does it equal to the whole average of the trip, right? So there's one point in time in between 0 and 3 where I will equal the average from 0 to 3. So using a visual approach, I kind of showed how that happened. And this is how it looks like on paper when you have to do all the number crunching. We try to figure out when does our derivative, the one dot, equals the average over this. Once you set them equal. So I looked at some of your answers, and I think at the time that I checked it, 75% of you all answered it correctly. It's impossible to average 80 miles an hour and never hit 80 miles an hour, right? It's impossible. So it can't happen. So if you ever get caught in that situation where you get that speeding ticket in the mail and you're like, nobody ever pulled me over, best believe you probably got clocked. And they probably found your average. And if your average is more than the speed limit, they can hit you with your average. So if you get hit with a speeding ticket in the mail, you don't know where it came from, if you're going to dispute it, your best chance of winning that one is to see if you can figure out how they got that average. If I get hit with a speeding ticket in the mail, you can't tell me where I started, where I stopped, the distance I covered, and how fast I covered that distance, I'm disputing that ticket every time. Probably going to win, too.